then you will be thorough enough in the concept. Okay. So guys, the module 2 is also done with that, and there is no doubts from you, and I think so. No one is posting any doubts or queries. I think you guys are listening clearly and you're getting everything what I am telling here. So I'm very happy on that because no doubts, no queries. Everyone are getting clearly, right? Means it should not happen like Srijit didn't clarify that point, or I didn't ask him that, I should ask him that. But these kind of thoughts should not be there in your mind. If you're having any questions, then please post it. Don't feel be don't hesitate to ask any questions, because these are for you only, right? For your upliftment only. Right. Can we proceed with module 2? Do you require 5 minutes gap? Or do you want me to ask any questions or what? Any questions? No? Can we continue with module 3? Module 3 is very simple. Just we will go for an overview. Okay. Satish, yeah, may continue. Guys, Rajiv, Kadam, Premsai, Umar, Vipul, Divyesh. Yes, we can continue, right? Okay. So, module 3. Module 3, network connections and types. Internet connections and types. Network attacks. Network, sec network security, technology devices and trends. Firewall versus UTM versus next generation firewall. Wireless LAN, sorry, VLAN, then VPN types and protocols. This is what we are going to deal with module 3. See, here it is very simple. I just want to give you an overview only, just to refresh your knowledge. In network connection, there are 3 types of network connections. Point-to-point network connection is there, broadcast or multicast is there, and multi-point is there. What is point-to-point connection? If one device exactly communicating with one another device, one to one device directly communicating with another device. So if I'm calling Premsai, me and Premsai in call, so that is something point to point. Broadcast or multicast connection. A device is sending one message over a network or sending copies of that to multiple recipients. This training is a broadcast or multicast connection. I am broadcasting the messages to you. I am broadcasting the information to you. One to many, exactly. Yes. Multi-point connections. What is that? It allows one device to connect and deliver message to multiple devices in parallel. For example, multiple connections allow one device to directly connect and deliver messages to multiple devices in parallel. So that kind of connectivity is called as multi-point connectivity. So a parallel type of communication. When we come to internet connection, we need to understand 2 terms, mainly ISP or IAP. ISP or IAP, Internet Service Provider or Internet Access Provider. What is that? It's a business or organization that provides access to internet and related services to customers. We know that, right? Airtel, BSNL, all these are ISP or IAP. Then WSP. WSP is Wireless Service Provider. Wireless Service Provider. As like ISP, in mobile now we are having internet connection, right? We are having Jio internet, we are having Airtel internet. In mobile is a wireless device. Mobile is a wireless device, and we do have internet. Then that type of service is wireless service provided by WSP, wireless service provider. This is about internet connection. Now you come into the type of internet connections. Generically, you can see dial-up. is one of the oldest method of connectivity. Dial-up connection with analog modems. Then broadband connection, then wireless connections. Dial-up with analog modems, broadband connections such as DSL, ISDN, lease line, cable internet, fiber connection, etc. Then wireless connection. See one by one. Dial-up connection. Dial-up connection, as the name indicate, what does it mean? There is a phone in your office, and from there would be a connection to your modem, right? And from there will be a connection to your computer system, and there would be some telephone lines as like carriers of the signals from your that's a telephone jack to that. There would be telephone lines going, and from there it is going ahead into the ISP's side, and there is internet. So this is how it's working as like a plain old telephone system in dial-up. This is something preferred by home users mainly, and the bandwidth is very less, and it would be ranging like 24 to 56 kbps. And without telephone line, dial-up is not there, right? Without telephone line, we cannot go for dial-up. And quality of connection speed and everything would be moderate or less. This is what dial-up. When you go for broadband type of connections like DSL, digital subscriber line, the speed is getting optimized or advanced in these kind of connection. So this is a particular type of connection provided by the ISPs, and here that analog modem, that kind of modem is replaced with the DSL modem. And again, here you can find three classes of connections such as ADSL, SDSL, and HDSL. ADSL is asymmetric digital subscriber line, SDSL is symmetric, and HDSL is high data rate, which is not common over here. It is very started in Europe and America. In ADSL technology is a transport that allows faster flow of information downstream and upstream both. In SDSL, it support one speed regardless of upstream or downstream flow. Means, as you know, when we go to many of the customer side, customer would be telling you uplink is 5 Mbps, if it is 5 Mbps, downlink is 10 Mbps or 7 Mbps. If uplink is 1 Mbps, downlink is 5 Mbps. So the bifurcation will be made by customer in many of the cases because it is followed by ADSL technology. In SDSL technology, a one speed, regardless of upstream, downstream, it is not, it doesn't matter. Irrespective of that, a common speed will be maintained in SDSL symmetric connection. And in HDSL, it can offer high data rate compared to ADSL or SDSL. That is what the main benefit. And in DSL service, data communication as well as voice communication, both data as well as voice, both can be handled simultaneously. In that modem, in analog modem or that dial-up connectivity environment, the challenge was internet would be getting disconnected frequently due to the voice communication. But in DSL, that challenge can be overcome, right? So that is about DSL. Then similar to that, we do have cable type of connectivity, cable connectivity. As you know, Asianet is providing, they're leaders in cable high-speed broadband. They are very reliable in connection. They use commonly coaxial cable type of cable, and there would be a cable modem installed into the customer premises, and it can provide you higher data rate like 1.5 Mbps to 7.5 Mbps in common, right? That is cable type of connectivity. Then ISDN is there. When we come to ISDN, it is something very advanced in terms of it is just not like just an internet connectivity. It's not like that. ISDN is having a wide scope in terms of voice process handling, and that local network itself, it can be established through that ISDN technology. It's actually a technology that can be applied into the ISPs. So when we come to ISDN, the advantage is that digital to analog and the analog to digital conversion, that process is not done in ISDN. ISDN itself is a standard. ISDN itself is a standard. So the conversion part is getting avoided in ISDN connectivity. And there are different channels they are providing, that is called as B channels, and with or BISDN, we call it as BISDN. ISDN, right, integrated service digital network, and it is having 128 kbps, that are right in common, and it can reach 1.5 mbps as well. And BISDN is offered with a fiber optic cable to reduce the distortion and attenuation. So such type of technology is ISDN. And there are another technology like lease line technology. In lease line, what is happening in lease line? As you know, a telephone line is running from ISB's end to the user's organization end. We are purchasing one dedicated line for intercommunication, and through their dedicated service we send the data. Normally what is happening, we use common channel, so that common channel would be used by everyone. So lease line would be dedicated. Lease line again, it doesn't mean like internet should be there in lease line. Lease line can establish a connectivity between two different points, one source and one destination, through the dedicated links provided by the service provider. And through that they can connect us into internet as well. And this can provide more bandwidth, and digital lease lines can provide 64 kbps in normal, and analogs are providing 9.6 kbps speed. This is lease line. Then fiber based connections are there. Optical fiber based technology is used for providing the connectivity, so that voice over IP or for video services, for all such kind of very sensitive things, this fiber optic technology is used. And here the significance is speed and quality. These two parameters would be achieved through the fiber optic connectivity based internet, compared to the DSL, or compared to that cable modems. We are getting more speed when we come to fiber optic communication. And as you know, in wireless link, that transmitter and receiver based communication is established through radio signals, and that is also common nowadays. So wireless internet is also a common thing every customers are using. Even we reach till 4G in that, right? Then MPLS, it is another type of connectivity. MPLS. When we come to MPLS, what is the full form of MPLS? Multi-protocol label switching. MPLS, multi-protocol label switching. Let me differentiate it with a normal or traditional IP network. In normal traditional IP network, what is happening normally? IP, no, that traffic is getting forwarded into the destination IP from that particular system or that particular network device. This is what usually happening. But when we come to MPLS network, The thing is that it is different than the traditional IP based network. That is point number one. And the point number two, sorry for that. And point number two, MPLS is a connection oriented method where the packets are routed along pre-configured paths. That path is called as label switched path or LSP. So there will be a dedicated path through which the packets will be moving from source to the final destination. That is the difference when we come to MPLS than the traditional IP network. If you ask me how the MPLS is working, then I'm just explaining it with the figure, the diagram. You consider host X. Host X is initiating some packet, some communication, some packet. There is a router in the side of host X. There is a router. If we call that router as ingress router. Ingress router. What is ingress router? A label switch router that is a starting point, that is at the starting point of communication is called as ingress router, ingress LSP, right? So this ingress router is taking that packet, and from there what is happening? It is tagging a label. It is tagging a label. Whenever a packet is received, the router uses that label. To identify. First, it will look into that label from where it is coming. It is from host X. For identifying that, it is looking into the label. Afterwards, where to forward the packet. Means it can see a lot of paths in front, and from that it will label the most suitable path or that layered service path through which the packet can be forwarded. So LSRA will add one more label. It is another unique label for LSRB because it is LSRB is the only available router in the next level to LSRA. So LSRB is again taking that packet and again it is adding one another label. If it is to Z, if the destination is host Z, then LSRB will be tagging with another label to LSRD, and from there again the process continues to host Z, right? Host Z or host Z. So that is it. So this is the flow through which, because in every stage a label is getting tagged by the respective routers. Routers can be ingress router or egress router. Egress router would be always the endpoint router. The endpoint, the final end of communication. That would be the egress router. Ingress router would be always a starting point or the source for a given layered service path. So every hop, it is using different labels, and switching is performed. So because of this, the communication is very fast, and it's simply forwarding the engines, and there is no need of additional configuration of anything. So this is how the MPLS networks are working. As you know, for Quick Heal, we do have MPLS, right? So from Pune, what will happen? So there is a chain of routers placed everywhere. So from Cochin, from Chennai, Bangalore, everywhere. So you can see that ingress routers would add a label and pass it to Pune if the destined host is at Pune. So this is how the communication is taking place. MPLS. Then now when we come to network attacks. In network attacks, we all know about network attack because we people are working in antivirus industry for several years, and we do know about network attacks. Network attack is usually an attempt for analyzing the network environment or monitoring a network resource or for collecting some information in order to exploit the ports or vulnerabilities to access the resources. This is what network attack. And a network attack can be passive attack or active attack. What is passive attack? Passive attack means its intention is just to monitor. It is just disabling any service. It is just monitoring. It's not disabling any service. It's not, what I can say, exploiting anywhere. It is just monitoring the user action. But in active attack, the perpetrator accesses the data, resources, and distracts something or misuses something, disables some services. Such kind of attack is called active attack. And the attacks can be generated inside the organization or from outside. So those kind of attacks are inside attack and outside attack due to many reasons, right? Then okay, there was audio issue. Let me repeat. So here we are looking into few common types of network attacks. I'm not explaining it. Just have a look on the slides. Network attacks commonly coming like eavesdropping. It's something a common type of what I can say attack. In eavesdropping, uh, it is happening. It is a passive attack. It's a passive attack. Attacker is trying to gain the access to the path of data communication. If I'm sending something to Premsai, attacker will interfere on that and he will just go for observing that communication or path. He will listen what kind of message is getting passed. He will try to interpret, not interfere. He will try to interpret or read the traffic. Such kind of attacks are eavesdropping. Okay, then data modification attacks. We already know, like ransomware. These are data modification. Whatever data is there in the customer system, that is getting modified by the attacker. That is data modification based attack. Then identity spoofing or IP address spoofing. We all know IP address is an identity of every computer connected in a network, internet, basically, right? So in certain cases, it is possible to spoof the IP address. It means falsely assuming the IP address. That is identity spoofing. Now, without disclosing their exact identity, they can communicate with us, or they can get in connect with our systems. After gaining access to our network or our system, the attacker will try to route the communication through them or modify the routing table or reroute the traffic or add their packet into it or delete the data, whatever it may be. So IP address spoofing or identity spoofing would be having serious impact. And one another type is password based attacks. In password based attacks, as the name indicate, they will use some technology. It can be spyware, it can be keylogger, whatever mechanism they want to follow, malwares, whatever it is, they could use it for taking the password, user information, user credentials, and will misuse it or use it for their benefit. Such kind of attacks are classified under password based attacks. Then another common type of attack is DOS or DDoS, denial of service or distributed denial of service. I'm just giving you simple example. I'm an attacker and Divyesh is the destination I want to attack. So what I'm doing, I'm sending some malicious traffic, I'm doing some port scanning, I identify something with him and I want to target with some packet. I'm doing it. My intention is one-to-one, one-on-one. My target is single and my intention is what? I want to disable Divyesh from using some network related services. For example, RDP. If once Divyesh is a victim to my attack, Divyesh would not be able to use set of one single or set of network related services in his machine. That is denial of service. Disabling the user, disabling the victim from using network resource or services after this attack. If it is DDoS attack, it is distributed, means one to many, means attacks can be more for disabling the service. Attack can be more in a distributed manner. We can do attack into one particular target and we can disable them from using multiple services. That is denial of service in a distributed way. One another attack is man in the middle attack. It is simple. A to B communication is there. A to B communication is there. A is sending some packet to B, but in between C is trying to add his packet and C is trying to reroute the traffic to B. Means for example, C want everything which is sent by A to B into C. So C is taking everything sent by A and routing something to B, and B feels that the data is coming from A. That misconception that can be generated by this interference of C. So these kind of attacks are called as man in the middle. One another agent is coming into the middle and diverting the communication and misinterpreting the communication. That is man in the middle. In compromised key attack, as like password attack, key is a secret code or a number necessary to interpret some information. So once someone is obtaining the key, for example, a RAR file is there. If we want to decrypt the RAR file, we should have the password which is protected, right? So if the key is compromised, someone can take it and they can get into the data. So that kind of attacks are called as compromised key attack. Then there are a few attacks happening with application layer services to bypass normal controls and all. So those kind of attacks are called as application layer attacks. These are attack classification. Now see, in this scenario, we should have some understanding on firewall. So firewall is the basic security technology or element that we introduce to block all kind of untrusted connections. Untrusted connections. For firewalls can be it can be a software firewall or a hardware firewall. Obviously, if there is a hardware firewall, it can be having a software module along with, right? So that is firewall. Let me divide the firewall in this manner. Types of firewall. First generation firewall. It is packet filter or stateless firewall. Second generation firewall is stateful firewall. And third generation firewall, it is application firewall. Please note it down. I am just coming to the evolution of firewall. FGFW first generation firewall is packet filter firewall of stateless. Then second generation is stateful firewall. Third generation is application firewall. What is it exactly? When we come to packet filter firewall, it was just filtering the packet earlier. It was stateless firewall. Means, stateless firewall means they were not having the ability to understand the status of packet. For example, continuously we are sending the packet in a network, right? So after receiving one packet, the next packet is coming. Is this packet related to the pre-sent packet or pre-communicated packet or the upcoming packet or not? That judgment cannot be taken by the packet filter firewall of first generation. Because of that, they are stateless. They were not keeping the record of state of a packet. They were just continuously, filtered out and drop the traffic based on some rules. They were unable to maintain the connection state. That's why they were called as a stateless firewall. So because of this, what was the disadvantage? Hackers could craft packet and pass it to the filters, right? because the packet is getting just moved through that, and even web traffic was not getting filtered there, and it was not monitoring for security. So we could not use it for security gateway. So packet filter firewall is a technology that we were deployed into the routers and switches actually, and it was in 1988 the first packet filter firewall implemented by Digital Equipment Corporation. In 1988, Digital Equipment Corporation developed the first packet filter firewall. Okay. Afterwards, the second firewall came, that was stateful firewall. Again, the same benefit. It was also the rule-based firewall only, but the benefit was there. What was the benefit? It was taking some decisions. It was taking some decisions based on the packet status. If the packet was logically related to the upcoming or the already processed packet, it will be interlinking the action with them. So state of each packet was maintained properly and decisions were taken accordingly by the stateful firewalls. Here also the disadvantage was regarding web-based attacks. Web-based filtering was impossible with stateful firewalls. Afterwards, what happened? The third generation firewall came, that was application firewalls. In application firewall, what they did, including HTTP is email traffic, the application initiated traffics were getting scanned by application firewalls. And again, there was host-based application firewall. As like in endpoint security, we are having host-based application firewall. And there are web application firewall, which was with appliance or with a server plugin we deliver to filter the application initiated traffic, right? That is called as web application firewall, WAF. It is an advancement done with that third generation firewall. So after this firewall, few other technologies came into the picture, like AV filter, antivirus filters to scan and inspect the signature or the packet for malicious traffic. Is the traffic is having any malicious behavior or not? It was getting scanned by AV filters. And IPS system came. IPS system and dedicated IPS appliances are also there for intrusion prevention. And these were working starting from network layer to application layer, IPS systems. Then mail protection gateways, some other appliances. Dedicatedly looking into emails, scanning for spams, those kind of protections were there. Then content filters, content filtering mechanisms were implemented for URL scanning, scanning categories of websites. Then application filters, specifically for blocking set of application. Then proxies for enabling security and for bypassing the direct communication. Means if we are not allowing any direct communication through implementing proxy, it will interpret what to be delivered to the destination through proxies. It is also called as the application level gateway, right? So all these are few technological terms or technologies that came into the picture for more security or for addressing the security need of the hour, right? Then UTM came, Unified Threat Management Appliance. It's a single appliance or under a single roof, everything is getting managed. It is having antivirus, routing configuration, VPNs, content filtering, load balancing, auto link failover, link aggregation, user management, DHCP assignment, all these kind of security related features came into one single appliance called as unified threat management device, right? After UTM, what happened? Next gen firewalls came. Next gen firewalls. UTMs were mainly focused on SME segment, like the throughput was limited. Next gen firewall, the term was coined by this Gartner during their 2003 in their few research notes and all. They published few notes on next gen firewall. What is next gen firewall? What is expected in next gen firewall? What would be the benefit on next gen firewall over UTM? So literally, UTMs and next gen firewalls are doing the same. They're having all common abilities. But next gen firewalls could handle more traffic. It can also accommodate more technology into it. It can also have high throughput rate. That is next gen firewall. And if you compare it with firewall UTM, you can see that starting from 1988 to 2009, there was a continuous change happened with, right? This is the change happened in the security industry. So next gen firewall is nothing which are typically designed for higher standard enterprise organization with more efficiency in terms of throughput handling, even though many of the features remain the same. That's it. So this is about firewall, UTM and next gen firewall. Then VLAN. Just I want to tell you a few things on VLAN. As we know, by using a switch, we are forming a LAN. By using the switch, we can also form VLAN, virtual LAN. The concept of virtual LAN is that logical grouping of devices under same broadcast domain. Same broadcast domain. For every switch, there is by default a VLAN is there. That is VLAN 1. By default, a VLAN is there. That is VLAN 1. The ports of the switches can be logically grouped and you can set other VLAN, VLAN 2, VLAN 3, like that. Sales VLAN, finance VLAN, like that you can group. So that that specific group will be acted as a single broadcast domain so that they cannot move their communication to the other broadcast domain. This is the benefit we are getting through VLAN. So broadcast traffic will be received and processed only by devices inside the same VLAN. And users can be grouped accordingly as per their physical location, and VLANs also provide us the security benefits. In our Seqrite Terminator, we cannot configure or create VLAN. We do have VLAN support. For example, the method of establishing VLAN connectivity is called as VLAN creation, and there will be a tag, tag we will use for identifying the host which are connected as a part of VLAN. That VLAN tagging can be supported by our terminator for providing security. That is what we are providing. We are not providing any offer to create a VLAN in our device. This is for your understanding I just mentioned. Then if you come to VPN, it is another wide area where everyone, currently every organization is having high demand. Like when we come to VPN, what is it? It's a virtual private network. Means accessing a private network over internet. This is what VPN. Accessing a private network over internet. So obviously how it is working? Users are connecting to internet through ISP. So if they want to connect or use with VPN, obviously there would be a VPN client software or some client level configuration need to be made with that particular host. VPN connections allow internet users to access the web from a VPN server, right? There would be a dedicated VPN server design that would be accessed by the user, and through that would be the communication will be established. We call that as a tunnel. A tunnel is getting established in between the source and destination. And through that tunnel, that secure tunnel, the communication, the connections are created. This is what happening inside a VPN. So VPN uses encryption kind of standards or technologies to to block certain content and to impart uh, security for traffic. Like I do have a few security standards over here. You can see it. PPTP, point to point tunneling protocol. This is a particular set of VPN protocol we have, right? And it is used in the Windows 95. It is very easy to set up, and it is an older protocol, and it is having it is vulnerable towards hackers and third parties. Point to point tunneling protocol. Then SSTP, it is another type of protocol called as Secure Socket Tunneling Protocol. It is used with Microsoft VPN connections. It uses SSL v3 standard to bypass the firewalls, and it is using AES encryption standard as well. It is compatible with that as well for safer connectivity than PPTP. So we consider this SSTP as more secure than PPTP kind of VPN connections, right? Then one another type of connection is L2TP plus IPsec. Actually, L2TP stands for Layer 2 Tunneling Protocol. It will not support encryption. L2TP will not support encryption. So L2TP is used along with IPsec, IP security that standard to enable encryption. So because of that combination, we can have secured encrypted traffic in VPN. That is L2TP IPsec. And we do have OpenVPN. OpenVPN or open source technology. It includes SSL v3 or TLS standard of protocol, and we can use Open SSL encryption library services for that. OpenVPN is highly configurable and is considered as one of the safest option in the web, right? Then the latest one is IKEv2, Internet Key Exchange. It is a request response pair protocol which uses X.509 certification standard of authentication as like a secret key based encryption standard. So IKEv2 is considered as the high-end technologically stronger protocol with VPNs. So these four are common types of protocols comes with VPN. So as per customers' preference, they can go for any kind of protocol. L2TP with IPsec is very common. SSL VPN is very common. IKEv2 is not common, but it's still considered as very technically highly, technically or encryption standard wise is having more security in terms of establishing connections. So this is all about VPN basics. So if we come to VPN itself is a very big topic. So I'm not coming into the deeper side of it now. So we have done with our content of module